our daily lives, we are constantly being bombarded with data. But here's the catch. Not all of this data is digital. On average, we hear about 30,000 words and we speak an additional 7,000 words every single day. To put that into context, that's about half the words in Harry Potter and the Sorcerer's Stone daily. And not all of this data is actually useful. Our version of trying to summarize that data is taking notes. But a lot of us are extremely bad at that, and we end up spending either too much time taking notes or we just jot down what's not useful. And here's where my solution comes in. My program can take in an audio stream, convert it into text, punctuate that text, and then generate key takeaways and summaries. This is extremely useful when it comes to lectures, meetings, or even just short calls with your friends that you want to keep track of. You don't have to put in any effort and it generates key takeaways right there for you. To get a better idea of how my program works, let's see how it handles transcribing this video. As you can see, it's able to get down most of the words correctly, and it's even able to capitalize and restore punctuation where needed. Now, if I was to break down my program into three parts, then you've got the automatic speech recognition, the punctuation restoration, and finally, you've got the text summarization. So let's start with how the speech recognition works. When it comes to automatic speech recognition, it's actually very complicated, and it can take multiple supercomputers and large data sets to create a working system. That's why I used a pre-made library, but I will go over how the system works. After taking in a raw audio stream, it converts it into waveforms, and then we can use neural networks to predict phonemes from those waveforms. Phonemes are specific sounds, and English has 44 of them. To get a better understanding of what a phoneme is, let's use the word live. Live has 3 of them, and they're the ul sound, the I sound, and the v sound. Together with these phonemes, we can use another neural network to predict which phonemes correspond to each word. And by passing it through the ASR system, I was able to take my audio input and convert it into a text output. Now that we have the transcribed text, the next step is to make it actually readable, since right now it's just a string of words. My approach for this was to first take a data set of online books and some of my friends' old essays, and I assigned classes to each of these words. These classes were 0, 1, or 2, with 0 representing no punctuation after the word, 1 representing a period, and 2 representing a comma. I then used a technique called word embedding to assign every single word a vector. What this does is it takes words of close meanings like dog, hound, mutt, or even chihuahua, and it assigns them vectors that are closer together. If we were to visualize this in a 2D scale, then dog and mutt would be much, much closer than words like phone and window. For this project, I used pre-trained glove vectors that have 50 dimensions. Going back to my model, I used a deep neural network for punctuation prediction. I started off with 5 word vectors as input, and I passed it through 3 hidden layers, each with dropout. The output layer consisted of 3 class probabilities for each of the 5 words, and in the end, my model ended up being able to classify periods pretty accurately, but was still a bit shaky with commas. The last step was to combine everything together and capitalize any proper nouns and the words at the beginning of each sentence. Now we have fully readable text that can be used for the final transcription. But wait, there's more. Going back to our goals for the project, we still have to summarize the text in a clear and concise way. My approach for this was to use extractive text summarization, which can categorize the most important sentences in a text and use that as an output for a summary. For this, it just takes a few steps. The first is to separate the transcription into a group of sentences and remove all of the punctuation and capitalization that we just added. Next, we have to get rid of any stop words or words that don't actually help us determine the meaning of the text. After separating the text into clean sentences, we can then create a similarity matrix of size x by x, with x representing how many sentences there are in total. The similarity matrix has values which represent how linked two sentences are with each other. And we can calculate these values by counting how many words are repeated in between two sentences and calculating the distance between them. We do this by creating a vector of all of the unique words used in the two sentences, and then we create two separate sentence vectors which add up the amount of times each of those words was used in the sentence. After that, we compare those two using cosine similarity, which takes the angle between both of those vectors. The lower the angle is, the more similar they sentences are. We can now take the values in the similarity matrix and multiply them by another matrix sized 1 by the number of sentences, and this lets us decide on rankings for each one. Finally, we can output a summary based on the sentences that had the highest ranks. And there you have it. That's my complete text summarization system, along with a transcription. Although my project is functional, it's far from being anything but a work in progress. There's a lot of space to develop upon in the future, potentially improving the way we declutter verbal data. The amount of information that we're going to be taking in daily is only going to rise, and being able to convert audio into summarized text is more important now than ever. And while my project might not be the complete solution, it's definitely an important piece of the puzzle.